Hello everyone. We'll wait for a few more minutes till everyone joins and then we'll start the session. Okay, so hello everyone. Welcome back to the week 5 TA session for drug delivery principles in engineering. So before we start, I would like to inform you that this session is being recorded and the recording will be uploaded on YouTube, as well as the presentation that we'll discuss today will be shared with you over Google Drive. So I hope your previous assignment went well. Someone had asked uh, in my last session that they faced problems while entering their answer as decimal form, and it was only accepting as integers. So if you are facing any such technical issues, you can post on the forum, and the designated people will look into it, and they'll help you in resolving these problems. I hope I'm audible to everyone. Can someone confirm?
Yes, madam. Yes, you are audible.
Yes, ma'am, you're audible.
Okay, so we'll start. So I'll share my screen now. Is my screen visible? Is the screen visible to everyone?
Yes, madam.
Okay. Okay, so today we'll discuss week 5 assignment problems for drug delivery principles in engineering. So these were the topics that were covered in previous week, that is protein adsorption and tissue engineering. So we'll start with the first question. Why do proteins adsorb on material surfaces? You have to pick one option. Because they are weak surfactants, because they tend to increase their activity after interaction with biomaterial surface, to prevent biofouling of the surface, because they are strong surfactants, the proteins will never adsorb on material surfaces to decorate the surface. Okay. Why do proteins absorb on material surfaces? Anyone would like to answer?
Option A.
Okay. Anyone else? A and B. Okay. I would request you to unmute yourself and speak the answers because it's difficult to switch between the two screens. If there is a problem, then you can go for chat. But yeah, it would be preferable if you just unmute yourself and answer. Anyone else has any other answer? Why do proteins adsorb on material surfaces? You have to pick one option.
Option A, ma'am. Proteins are the weak surfactants.
Okay. Anyone else?
Option A.
Okay. Anyone else has any other answer other than option A? Okay. So option A is the correct answer because they are weak surfactants. So they act like synthetic surgeons, but they are relatively weaker than that. So proteins are composed of amino acids. Some of these amino acids are hydrophilic, whereas others are hydrophobic. So this relative difference in the hydrophobicity leads to their action as weak surfactants. So the hydrophobic part will get attached to more hydrophobic region, and hydrophilic will part will attach to hydrophilic region. So the next question, which of the following two statements are false about protein adsorption in biomaterials? The options are limited adsorption sites and consequent competition means that not all proteins in the plasma phase can be represented on the surface. Driving forces for adsorption are the intrinsic surface activity and bulk phase concentration of the proteins. Once a protein gets adsorbed, it doesn't come off. Surfaces vary in selectivity of adsorption. Adsorption is highly dynamic. Proteins always lose their structure and function after adsorption. Biological activity of the adsorbed protein varies on different surfaces. You have to select two statements that are false.
Option C and F, madam. Option C and F.
F.
Yeah, C and F.
Once a protein gets adsorbed, it doesn't come off, and
Yeah.
proteins always lose their structure and function after absorption.
Ah,
Okay.
yeah, I think those both.
Okay. Anyone else?
CNF.
Okay. Anybody else would like to answer? Which of the following two statements are false? Nobody else? Okay, so C and F are the correct options. Once a protein gets adsorbed, it doesn't come off. That is not the situation. So there is competitive adsorption, wherein the equilibrium adsorbed protein layer composition is determined by total and relative protein concentrations. So initially, when the surface is uh, exposed to proteins, the initially adsorbed proteins are displaced by other proteins over a time, which is determined by thermodynamics. And then protein may denature on adsorption. So some proteins denature doesn't mean all the proteins will always lose their structure. So based on the exposure of their hydrophobic or hydrophilic surfaces, if they are getting if the core part is getting adsorbed and it is exposed and it is changing the structure, then only it will be denature or they will lose their structure. But if it is a hydrophilic surface, the outer surface will mostly attach to the surface, which might not lead to loss of their structure and function. So proteins always doesn't necessarily lose their structure and function after adsorption. So let's move on to the next question. The next question is, consider that cells are resuspended in a rich protein solution, say FBS. This suspension is added on top of a biomaterial. Rank the interaction of different components, that is cells, water and proteins, with chronology of their interaction with surface of biomaterial. I'll give you some time to read the options and let me know what you think the answer is. What is the order in which these components will come and interact with the surface of biomaterial? cells, water and proteins, what will be their chronology of interaction when exposed to surface of a biomaterial?
Madam, option C.
Option C, okay.
Option
Ma'am,
C.
option C.
Okay. Anyone else? Anybody else would like to answer? What will be the chronology of interaction of cells, water and proteins? Anybody else would like to answer? Okay, the correct answer is water, protein and cells. First water will come and wet the surface, and then that will be followed by proteins, and proteins will then after the proteins cells will come and interact with the exposed biomaterial. Now the next question, what are the common techniques to quantify protein adsorption on material surfaces? You have to select two options: western blotting, northern blotting, southern blotting, RT-PCR, qRT-PCR, AFM, eastern blotting, surface plasmon resonance. What are the common techniques to quantify
First
protein?
option and last option.
First option and last option. Okay.
Ma'am, first and last option.
Okay. Anyone else?
Yes, ma'am. First and last option.
Okay. Anybody else? Yes, first and last option is the correct answer. Western blotting and surface plasmon resonance. So these are the protein adsorption quantifications. Uh, so we have to incubate, then centrifuge, followed by SDSP gel, and then Western blotting. In Western blotting, these after running the SDS page, it is transferred to a membrane, and then we allow it to interact with antibodies. Based on that, we quantify what are the proteins that are adsorbed. And surface plasmon resonance is another widely used protein adsorption quantification technique, wherein there is this uh, prism which is coated with a metal surface, and there is an incident light, and these excites the free electrons in the metal surface. So based on the changes on the surface of the metals due to binding, the refractive index or the angle of the surface plasmon resonance angle will change. That helps us to quantify the rate of protein adsorption in over the surface. Now, what is Vroman effect? You have to pick one answer. Replacement of thermodynamically favored proteins by kinetically favored proteins from a surface over time. Replacement of kinetically favored proteins by thermodynamically favored proteins from a surface over time. Replacement of small 10 kDa proteins by large proteins 15 kDa, more than 150 kDa from surface. Replacement of large proteins more than 150 kDa by small proteins 10 kDa from surface. And replacement of soft proteins by hard proteins. What is Broman effect?
Ma'am, option B.
Replacement of kinetically favored proteins by thermodynamically favored proteins from a surface over time. Okay.
Option B.
Okay.
Option B.
Okay. Anyone else?
Option B, ma'am.
Okay. Anyone else would like to answer? What is the correct option for Broman effect? Okay. Yes, those of you answer replacement, the second option, that is the correct option. Replacement of kinetically favored proteins by thermodynamically favored proteins from a surface over time. As we discussed earlier, adsorbed protein layer composition is very dynamic, and initially adsorbed proteins are more kinetically favored, which are displaced by other proteins over time, which is determined by thermodynamics. This is called Broman effect. Now the next question. When nanoparticles are injected in vivo, the proteins form a layer on the surface of the particles. What is this layer called? Nucleophilic substitution of proteins, nucleophilic addition of proteins, protein corona, electrophilic addition of proteins, and electrophilic substitution of proteins.
Ma'am, protein corona.
Option C. Protein corona.
Yeah, option C, ma'am, protein corona.
Okay,
Option C, ma'am. Protein corona.
okay, good. A lot of answers this time. Anybody else?
Option C, ma'am.
Okay. We'll wait for some more time if anyone else would like to answer. What is proteins, the proteins that form the layer on the surface of particles? What is the layer called? Anyone else would like to answer? Okay. Yes, it is the protein corona. The proteins that form a layer over the nanoparticle is called corona, and that is further classified into hard corona and soft corona. If they are more tightly packed and attached to the surface, it forms a strong layer, and then that is followed by more loosely attached proteins that are attracted towards them but are over the they form a secondary layer that are attracted to the initially attached proteins, not the surface directly. That forms a soft corona, and the inner core forms a hard corona. Okay. Now the next question. If cells are transplanted from a human donor to a human acceptor, what kind of transplant is it? Is it allogenic,
Option A.
autogenic, xenogenic, or antigenic? Sorry.
Option A, ma'am.
Okay.
Option A.
Allergen.
Option A. Allogenic.
Okay.
Option A, allogenic.
Okay. Anyone else? If cells are transplanted from a human donor to a human acceptor, what kind of transplant is it? Anyone else would like to answer? Yes, it is allogenic. So allogeny, when within the same species, transplantation is done. That is here both are human donor and human acceptor. Autogenic is transplantation in the same individual. This when from a different part of the body it is transplanted to some other part, it is autogenic. Xenogenic is between two different species. So when from suppose from pig to human or uh, mouse to pig or some other between two different species, when there is the donor are from two different species, donor and acceptor, it is xenogenic. Next question. For transplantation in humans, allografting is one of the most common approach. What are the major drawbacks of this approach? You have to select two options.
1 and 2.
Lack of
1
donors
and
and
2.
spread of disease.
1 and 2.
Okay. Anyone else?
One and two, ma'am.
Okay. Anyone else would like to answer? What are the major drawbacks of this approach? Allografting. Okay. First and second options are the correct options. Lack of donors and there is spread of disease. So transplantation from another human is the most clinically used practice, that is allography. Lack of donors, spread of disease, and immune rejection, that is half-life of organ is around 10 to 15 years. These three are the major disadvantages of this transplantation technique. Next question. Which surface is more favorable for protein absorption and why? You have to select two options. Hydrophilic surface because it is more charged. Hydrophobic surface because it is energetically more favorable to displace water and replace with protein. Smooth surface because of available surface area. Rough surface because of available surface area. Which is more favorable for protein absorption?
Hydrophobic and rough surface.
Okay.
1 and 4.
1 and 4. Okay.
2 and 4.
2.4.
2 and 4. Okay. Anyone else? Which surface is more favorable for protein absorption? Anyone else would like to answer? Yes. 2 and 4 are the correct options. hydrophobic surface because it is energetically more favorable to displace water and replace with protein, and rough surface because of available surface area. The next question is a numerical question. Consider that the proteins adsorb on the surface of an implant using a monolayer model according to the Langmuir adsorption isotherm. Theta equals to Kp upon 1 plus Kp, where theta is the ratio of sites occupied by the molecule and total sites available for adsorption. K equals to 2 millimolar inverse, and P is the concentration of the molecule. A cytokine is trapped inside a chamber at concentration of 2 millimolar if they are at 10 power 5. Total binding sites, how many of them will be occupied at steady state? Assume equilibrium conditions. Right answer as multiple of 10 to the power 4. I'll give you some time to solve the question and you can let me know what your answers are.
Ma'am, could you please repeat the answer of question number 9? My internet got disconnected.
Question number 9. The question was which surface is more favorable for protein adsorption and why? The correct answers are hydrophobic surface because it is energetically more favorable to displace water and replace with protein. And another option that was correct is rough surface because of available surface area. So because the surface is hydrophobic, already it is repellent to water. So it is easier for protein to replace this water and get attached to the protein.
Ma'am,
Yes,
can you explain the first and second questions once again, ma'am?
first and second,
Yes, ma'am.
first and second questions, you're saying?
Hmm.
Yes, we'll go through all the questions again. But first let's complete the question number 10. Has anyone solved the has anyone got any answer? What is how
Answer
many are the total occupied sites in the
8.
steady state? 8. Okay.
Yeah, I got answer 8, ma'am.
Okay. Anyone else? We have got one answer, 8. Anyone else has any other answer? Or even 8 as an answer? Herein you have to calculate the number of occupied site at steady state. So theta is basically total number of occupied sites by total sites. So from theta we can get the occupied sites, and to calculate theta, k and p both are given. So first you have to calculate theta. and then multiply the number with total sites. You'll get the answer.
Each, ma'am.
Okay. Anybody else? Anyone else who was able to solve the problem? What is the answer? Okay, those who said
7,
8.
ma'am.
Sorry?
7.
7. Okay. Well, 8 is the correct answer. So as I said, we have theta is the sites occupied by total sites. So first we have to calculate theta to get the number of sites occupied. And here K equals to 2 millimolar inverse, P equals to 2 millimolar. So, and the total binding sites that is given is 10 to the power 5. So if you put those values in theta equals to Kp upon 1 plus Kp, you'll get 4 by 5, which is 0.8. And the number of occupied sites would be theta into total number of sites, which is 0.8 into 10 power 5. If you convert it, it is 8 into 10 power 4. Since the answer is asked to write a numerical in terms of as a multiple of 10 to the power 4, the answer will be 8. Okay. Anybody has any doubt in this question?
No, ma'am.
Okay.
No, ma'am.
Okay. Okay. So now we'll start again from question number 1 for those who missed. So the question number 1 is, why do proteins absorb on material surfaces? We have to select one option that is correct. So the correct answer here is because they are weak surfactants. So proteins have both hydrophilic and hydrophobic parts because of their amino acids, and because of these different regions that are hydrophobic and some regions that are hydrophilic, they act as weak surfactants. The next question was, which of the following two statements are false about protein adsorption in biomaterials? So the options that are false are, once a protein gets adsorbed, it doesn't come off. And the next option is, proteins always lose their structure and function after adsorption. These two options are false. So once a protein gets absorbed, it doesn't come off. That is not the situation. There is always competitive adsorption, and this protein adsorption is dynamic. So initially adsorbed proteins that are kinetically favored are displaced by other proteins that are determined by thermodynamics. And in this way, they continuously get replaced by more thermodynamically stable proteins. And the kinetically ones gets continuously replaced. So proteins do get do come off after getting adsorption. And then proteins always lose their structure and function after adsorption. So no, uh, if only their hydrophobic part or anything, the inner core or something that is attached and it gets exposed, there is a change. But if there is more hydrophilic surface and the hydrophilic parts of the proteins get attached to the hydrophilic surface, then there is not much change to their structure and function. So that this is not the case always that the protein will lose their structure and function. Sometimes they may not lose their structure and function. The next question was, consider that cells are resuspended in a rich protein solution. Am I audible? Can anyone confirm?
Yes, ma'am.
Okay. So the third question was, consider that cells are resuspended in a rich protein solution, say FPS. The suspension is added on top of a biomaterial, and we have to rank the interaction of different components, cells, water, and proteins with chronology of their interaction with surface of biomaterial. So when we are exposing a biomaterial to cells, water, and protein, first wettability will be there, water will come in contact with the surface, and then proteins will come, and then cells will come after the proteins. So water, protein, and cells will be the chronology. The next question was, what are the common techniques to quantify protein adsorption on material surfaces? So the answers are, you have to select two options, Western blotting and surface plasmon resonance. So in Western blotting, SDS page is done, that is followed by transferring of this to a membrane and then incubation with antibodies through which we can detect the adsorbed proteins. And surface plasmon resonance is another technique through which we can detect the protein adsorption. So in this technique, the prism surface is coated with a metal, and based on the on on the light source, incident light source, the free electrons in the metal surface get excited. That leads to a angle of refraction. These angle of surface plasmon refraction angle changes depending on a slight change over the surface. So if there is binding or any other changes occurring on top of the metal surface, this will change the angle of surface plasmon resonance, and then this will lead to a detection of protein quantification. We can quantify this way. Now, what is Froment effect? What is the correct answer? The correct answer is replacement of kinetically favored proteins by thermodynamically favored proteins from a surface over time. So initially we were discussing that it was dynamic. There only it was mentioned that initially all the proteins will be adsorbed based on their kinetics, and then over time it will be replaced, determined by thermodynamics. The next question was, when nanoparticles are injected in vivo, the proteins form a layer on the surface of the particles. What is this layer called? This layer is called protein corona. So this is how a corona is formed. So the inner core is the nanoparticle, and then based on the uh, proteins, proteins that are tightly attached or more favored and strongly attached to the core will form a tight packing hard corona, and then there are soft proteins that are further uh, attracted to these attached proteins that are loosely attached and form a secondary layer, that is the soft corona. Next, if cells are transplanted from a human donor to a human acceptor, what kind of transplant is it? Yes. So if cells are transplanted from a human donor to a human acceptor, the transplant will be allogenic. Autogenic when it is done in the same individual from a different part from one part of the body to a different part. Xenogenic is when it is the donors and acceptors are from two different species. The next question was, for transplantation in humans, allografting is one of the most common approach. What are the major drawbacks of this approach? We have to select two options. So lack of donors and spread of disease are the two options that are the major drawbacks of this approach. Another major drawback is immune rejection. that is half-life of organ is around 10 to 15 years. Which surface is more favorable for protein adsorption and why? You have to select two options. The first option is hydrophobic surface because it is energetically more favorable to displace water and replace with protein. And the next option that is correct is rough surface because of its available surface area. Now the last question, it's a numerical question. So consider that the proteins adsorb on the surface of an implant using a monolayer model, and the Langmuir adsorption isotherm is given as theta equals to Kp by 1 plus Kp. Theta is the ratio of sites occupied by the molecule and total sites available for adsorption. K equals to 2 millimolar inverse. P is the concentration of the molecule. Here P, a cytokine that is trapped inside a chamber, has a concentration of 2 millimolar. So if total binding sites are 10 to the power 5, what will be the number of occupied sites? So as it is given, theta is the number of occupied sites by total sites. So to get the number of occupied sites, we have to calculate theta first. So for theta, K and P values are given. K equals 2 millimolar inverse, P equals to 2 millimolar, and total binding sites are 10 to the power 5. So theta equals to Kp by 1 plus Kp, that will come around 0.8. And the number of occupied sites would be theta into total number of sites. That is 0.8 into 10 to the power 5, which is basically 8 into 10 to the power 4. So the answer will be 8 because we have to give the answer in the form of multiples of 10 to the power 4. Okay. Now anybody has any doubt in any of the questions or wants me to repeat any question again? Okay. Anybody has any doubt or wants me to explain any other question again? Am I audible?
Yes, ma'am.
Okay. Okay. Anyone has any doubt in this in today's session or in any other previous sessions or wants me to discuss any question again or wants me to repeat, then we can go through again. If not, we can close this session now. If if you have any doubt in the lectures also, you can ask. We can discuss that as well. Any one of you has any doubt or wants me to repeat questions again? You can let me know. Bhagyashree and Thirumurugan, do you have any doubt or anything to ask? No, ma'am. Okay. If not, you can leave the session. You're welcome.